Hey, it's time for math class. Manufacturing Math, Lesson 1, Part 3, in which we cut round holes out of square pegs. Okay, our ongoing mission is to turn a square into a circle. And we know by now that's easy, right? You just start with a square and you cut away everything that's not a circle. And that's great. That's a terrific review, and that brings us right up to date with everything that we've learned so far in this video series. But we learned last time that you can cut in a circle pattern. You can cut in what appears to be geometrically proper, constrained along the X and Y axes. You can cut what seems to be a circular pattern and still end up with a square. But we don't want a square. We want a circle. Our client wants a circle. Our boss wants a circle. The job spec calls for a circle. We need to cut a circle. So if it was you, how would you turn a square into a circle? Well, let's look at some options. Could you, for example, drill bigger holes? Well, you could, and that's actually not a bad idea, but it's not real helpful, and here's why. If you increase the size of the holes and leave them in the same diamond pattern, you end up with a diamond just made out of bigger holes, not the circle that our job specifications call for. Of course, the obvious answer is to just drill the holes in a circle. Yeah, duh, right? But sometimes the obvious answer is also the best answer. If we could just take that diamond pattern and reshape the holes that we're cutting into a circle, we would end up with the circle that we're trying to get. So today's brain bender is, how do we get those holes arranged in a circle? How would you do it? Well, you could guess at it, and that's actually a fairly common method. Just keep drilling holes until you get a circle. But it's slow and it's messy, and depending on the kind of material you're using, it can be very expensive. So here's a hint. We need to know the size of the circle we're working with. And more than likely, we need to just go check the job specs, because the job specs will probably define the size of the circle generally in the terms of their diameter. Yeah, bummer, right? Here we go with the geometry terms. But take a deep breath, because this one is actually going to make sense. Let's say the job spec calls for a 3-inch diameter hole cut out of our material. Diameter is just the distance across the circle measured at its widest point. It's like the circle's belt line. And here's a rather tasteless way to remember. Diameter is something that's cut in half. So if you cut something in half, most likely it will die. If one of us was cut in half, we would die. And that's tasteless and gross, but it might be a good way for you to remember the nature of the diameter of a circle. The widest point part is important, because if we measure across the circle at its widest point and then stand right in the middle, every point around the edge of the circle is exactly the same distance away from us. It's really important. It's worth spending a minute with. Did that make sense? Let's try it one more time. If we measure across the circle at its widest point and then stand right in the middle, that's us standing right in what's called the center point of the circle, every point around the edge of the circle is exactly the same distance away from us. So why is that important? Well, let's go back to the checkerboard for a second. Remember that position we called home? 0, 0, the place where we considered the X and the Y axis to meet at 0, 0. It was the place that it's the base from which we move around our design, and also the base from which we measure. Home can be anywhere on the board, or home can be anywhere on our design. Now, in our original example, we just arbitrarily set our green checker piece at home on the x-axis, a few squares in from the left border, and on the y-axis at the very front. That's just the arbitrary spot that we chose to place home on the board. We could, in this case, since we're cutting a 3-inch diameter circle, we could place home right in the middle of that circle. So if we know we're cutting a 3-inch diameter circle, we also know exactly how far away from the center to cut. if we place home on the center of the circle, we know that every point around the edge, all the way around the circle, is exactly the same distance away from us there in the center. But how far? Well, we have a 3-inch diameter circle, and we want to place our home, our center point, such that every point on the edge of the circle is exactly the same distance away from us. So would we make it 3 inches? Would we make it 1.5 inches? Or would we make it something else? Well, let's take a look. If home is spot on in the middle or the center point of a 3-inch diameter circle, every point around the edge of that circle is 1.5 inches away from us, right? So if we measure out 1.5 inches and cut a complete arc from directly the middle of that circle, our home, we have a 3-inch diameter circle. So our answer for now is that we want to measure 1.5 inches from the middle of that circle, cut a complete arc, and we'll end up with a 3-inch diameter circle. Does that make sense? If it does, great. If it doesn't, it's worth stopping the video, going back and reviewing, because this is a really big deal. You've just done something very important in terms of your manufacturing math. You've just used the diameter of a circle to figure out something that's called its radius. Radius is half of the diameter of a circle, and it is absolutely the key to understanding how to cut a circle out of a piece of material. So you now have a key idea behind cutting or drilling a circle. You now know what to do when you're asked to cut a circle out of a piece of material. The next thing we're going to do is consider how to do it. Good work. You're doing great. If all of this makes sense, you've just learned some very important concepts in manufacturing math. Now we're just going to keep adding details. Look forward to seeing you in the next segment of this video. Thanks.